Ladies and gentlemen, welcome to our webinar on comprehensive evaluation strategies and tools for LLM applications. I am Tanishka, and on the behalf of Walking Tree Technologies, I extend a warm welcome to each one of you. It is truly a pleasure to have such distinguished audience joining us today. Before we dive into the details of our agenda, let's take a moment to welcome those who are still joining us. Hi Scott, hi Abhilasha.
Hey, Tanishka. Good evening. Good morning for
Hi,
me.
Tanishka.
Good evening for you.
Hi, Scott.
Yeah.
Hey, Abhilasha.
So for those who are unfamiliar with our organization, Walking Tree Technologies is at the forefront of driving technological innovation. We specialize in conceptualizing and implementing state-of-the-art solutions, particularly in emerging technologies like AI. Today's webinar shifts our focus towards the evaluation of LLM applications, a critical aspect in ensuring their effectiveness and reliability. At the conclusion of the webinar, we'll reserve some time to address your questions and insights. Please feel free to submit your queries in the Q&A box provided during the session. Let's make this an interactive and enriching discussion. So without further delay, let me introduce our esteemed speakers for today's session. Kicking off our agenda, we are honored to have Scott Seabold, our Chief Technology Officer, lead the way. With an abundance of experience and forward-thinking vision, Scott is an ideal guide for today's exploration into the realm of LLM applications. His extensive insights offer participants a comprehensive understanding of the intricate landscapes of LLM applications, showcasing a critical role of evaluation in ensuring robustness, ethical use, and effectiveness. Scott promises to provide valuable perspectives and strategic insights, guiding our audience through the complexities of evaluating LLMs and application for optimal deployment and impact. Now, our solutions architect as a guiding force in the exploration into LLM applications. With a wealth of experience and forward-thinking approach, Abhilasha is well suited for today's discussion. Her insights will provide participants with practical strategies for effective evaluation, drawing from her extensive background as a solutions architect. Abhilasha's expertise will illuminate the significance of evaluation in ensuring the reliability and ethical use of LLM technologies. Participants can expect valuable perspectives and strategic insights as Abhilasha navigates the complexities of LLM application evaluation, offering actionable guidance for enhancing their deployment and impact. The webinar on comprehensive evaluation strategies and tools for LLM applications delves into the intricate landscape of language model applications, emphasizing the critical need for thorough evaluation to ensure the efficacy, ethical use, and reliability. The session aims to equip everyone with an understanding of LLM-based applications across various industries. Now, let's delve into the heart of the webinar. Scott and Abhilasha, the floor is yours to guide us.
Okay. Thank you very much. Let me just share my my screen here. Oops, I think I'm off a little. There we go. I think that matches up a little better. Okay. Thank you, Tanishka, for that introduction. And what I'll do first is kind of take us through a couple of the points on this agenda, and that'll be the landscaping of LLM-based applications, as well as what is the significance of evaluation in LLM-based apps. So I'll cover those 2 points, and then Abhilasha will discuss strategies for effective evaluation, and then we'll look at tools and frameworks for evaluation with a demo included in that as well. So so hopefully my voice holds up. It's things are going around in my area like crazy, but we'll give it our best. And so what I like to do is like I always try to think. I try to think in terms of let me understand why we're doing something before we do it. So I'll kind of handle that part of things. So just to kind of start overall, why would we evaluate LLMs above and beyond what we do to determine the accuracy and the fluency? But it's also important to look at things like fairness, robustness, scalability, and the very nuanced things about it, right? So how does it really fit into that application ecosystem? So we'll cover the whys on that and then talk about some strategies later on as well. So just looking though first at what's the landscape of large language model apps, right? So the first area that I'll talk about is just the LLM ecosystem itself, right? And to begin, you've got foundational models, and these are really based on they're models that are based on large language models, which serve as like the starting point, if you will, right, for various applications. So give us a good starting point, whether it's training autonomous vehicles or whatever the case might be, if it's financial, if it's whatever the case, right? So whatever is specific to the application that you're dealing with. So these foundational models provide, like it says, a foundation to the groundwork for that. And they're typically pre-trained, right? They're trained on really vast amount of data, and they can perform a wide range of things like natural language understanding and generation tasks, and then the capability to handle multimodal content. And what this refers to is it refers to the ability of the LLM to understand and process information from various forms of data like text, images, possibly audio even. And what they're doing is they provide coherent outputs for you. And then LLM alternative, LLMs, as far as open source alternatives to say the proprietary models. And with this point, it's just to know that, hey, there are alternatives to the proprietary that are open source, and those really provide accessibility and customization opportunities for developers, and maybe the chance to run those on premise, right? So you're not having to go out. Maybe you've got data that's very particular to your business and it needs to be very private. These open source models can provide a foundation, even for applications like that, when you need to have a model that maybe runs within your own shop, right? And then in terms of LLM ecosystem, prompting techniques to improve responsive quality. So these are strategies that use to interact with LLMs using really carefully crafted prompts to elicit a better and more accurate and more relevant responses from the models. And then we have, in terms of data discovery and data augmentation, this really involves using LLMs to find and create new data sets or enhance existing ones to improve machine learning model performance. So another important part of the ecosystem right now too is just the generic. What are some of the generic use cases for LLMs? And one of those being summarization, right? LLMs can condense long pieces of, say, text into shorter versions, and they capture the most important information, which is really useful, for quick content digestion. Also, text generation. These models are capable of generating human-like text, which can be used in a variety of applications like content creation, dialogue systems, and much, much more. And then there's the question answering and query agents. So LLMs can be used to build systems that answer questions, or maybe they fulfill retrieval tasks, acting as like automated agents that understand and respond to users' queries. And then there's the use of LLMs for entity extraction, right? So now this process is identifying and classifying entities, things like, names, places, organizations that are in text. And that's crucial, right, for information retrieval and organization. And then, of course, language translation too is another part of that, right? LLMs can translate text from one language to another, can really facilitate communication across language barriers even. And then finally, you've got, RAG prompt engineering. So RAG stands for retrieval augmented generation. And that's a technique where the LLM retrieves information from a database or a data store, right, to enhance the quality of the output that's generated. And then we also have like specific implementations as well, right? So specific use models trained for specific behavior, like maybe chat models and for question answering. And so these type models, that have been trained or they've been fine-tuned for specific tasks, like conversational AI, that can, things that can interact with users in a more natural, human-like way. And then there's the actual fine-tuned models, fine-tuned and tuned really for specific behavior. And these models start as foundational models. So they start as foundational LLMs, but they're further trained on a specific data set for a particular task to improve the performance in that particular domain. And then finally, in the landscape of LLM apps, we have the tool ecosystem, which Abhilasha will talk about quite a bit later. But we have things like embedded models. Embedded models are used to convert things like text into numerical representations or vectors. And those capture the semantic meaning of words or phrases. And that's really essential for things like natural language processing tasks, for example. Vector stores. These are kind of data stores designed to store and allow efficient querying of vector data, which is used in similarity search and other machine learning type operations. Memory and cache, that refers to the system components that store data temporarily for quick access by the LLMs, and that enhances performance and response time. And again, we'll talk about some of these in a little more detail later, but just to get you familiar with some of the terminology. Observability is a big thing we'll talk about today. The ability to monitor and understand the internal state of the LLM systems, typically for like performance tuning, debugging, and ensuring that the system is really working as it was intended to work. And then the deployment framework is very important too, because these frameworks assist in the process of deploying LLM applications into production, handling aspects like scalability, versioning, maintenance, and then the evaluation framework, which is a big part of our webinar today too, is that these framework really provide methodologies and metrics to assess the performance of the LLM, and they ensure that they meet the required standards before and after deployment. So that's just kind of a view of the landscape of LLM-based apps. Let's talk a little bit here about the what we call the 5 pillars of observability, right? And these are kind of important concepts to kind of grasp as we think about the subject of evaluation of LLMs. And that first pillar is evaluation, right? And it's a cornerstone of LLM observability. And using like a separate LLM dedicated to evaluate allows for an unbiased assessment of responses, or the evaluation model is really not influenced by the training of the original LLM, and it ensures the quality of that response is objective and it can be objectively measured. The process for doing this involves feeding prompts and data into the LLM, capturing the response, and then running this through the evaluation library, which provides a performance metric and evaluation score for you. So it really, in other words, it helps identifying areas where the LLM might need improvement, and it ensures that the model's outputs remain really high quality over time. And then another pillar is LLM traces and spans, right? So tracing and spanning are about gaining visibility into the workflows of the LLM operations. By examining those trace and spans, what we can do, we can pinpoint where and why a workflow might be broken down or isn't producing the expected outcome. And these detailed inspections are crucial for debugging and optimizing the LLM. And it provides insights into each step of the LLM's decision-making process as well. Prompt engineering, term that's used, probably overused, but prompt engineering is really the iterative process of defining the prompts used to elicit the best possible response from the LLM. So by adjusting the templates and the phrasing of prompts, we can significantly influence the quality and relevance of the LLM's output. And this really requires continuous experimentation to find the optimal prompt structures that lead to those improved results. And so that makes it really a vital part of the LLM's development and maintenance cycle. And then the next pillar we have is search and retrieval. And this pillar focuses on the LLM's ability to retrieve relevant information in response to queries. It involves things like fine-tuning mechanisms that the LLM uses to search through its knowledge base and present the most appropriate content. So it improves search and retrieval capabilities and is, of course, key to delivering accurate and contextually relevant responses. And of course, that is obviously very important for applications like chatbots, research tools, and things like that, especially. And the fifth pillar is fine-tuning. And fine-tuning is the process of really retraining the original LLM on data that is specific, to a particular use case that a company needs. So this allows the LLM to become more specialized in a certain area, right? So that's going to increase the effectiveness of that specific task for that specific industry. All right. So next, let's talk about, well, what is the significance of evaluation in LLM apps? And of course, the first one that I'll talk about is the importance of a robust evaluation strategy, right? So evaluating LLMs, it goes really beyond the preliminary testing, right? A robust evaluation strategy is key. It is the key really to transition from a proof of concept to a reliable production system. So, and this includes includes really comprehensive testing that covers not just the typical use cases, but also edge cases, stress tests, and so forth. And the aim is really to ensure the model's responses are reliable and that the performance is consistent across various scenarios, right? Just like we would do in just standard application development, the LLM has to kind of fit into that same paradigm, right? It's got to be robust. It's got to be dependable, just like we have done traditional application evaluation and testing as well. And, the next point in the significance of evaluation is the stochastic nature of LLMs, right? So the randomness of the nature of LLMs. So LLMs are really inherently probabilistic. That meaning that really that their outputs can vary even with the same input. So it's crucial to understand and communicate that while this, stochasticity, well, that's a huge word for me to say, but it allows for varied and rich responses, right? So it can also lead to unpredictability and performance, though. So really, because of that, it is really essential to conduct extensive evaluations to understand the model's range of behaviors and set appropriate expectations, right? And this evaluation really should be an iterative process that helps fine-tune the model to ensure stability and consistency in the responses. And next we have, initial impressive results. Really early demonstrations of LLM applications can be really impressive, right? They show the model's ability to handle tasks with a small amount of training data. However, the initial results should be viewed with cautious optimism, right? So they often represent the model's potential rather than a guaranteed performance. So it's important to recognize the limitations and understand the initial success doesn't always scale without further refinement. So there's more that's needed around this, right? So an initial demo is just the first step. The model has to, the model's got to be challenged with more complex and diverse data sets to truly assess its capabilities. Matching production data distribution. So it's imperative that the data used to evaluate LLMs really closely matches the model, what the model will encounter in the real world. So this means that things like test data sets should reflect the variety and complexity and distribution of the production data as closely as possible. And by doing this, what you do is you can better gauge how the model will perform when faced with actual user interactions. And some of what helps this a lot too, right, is being able to synthetically produce that data, which we kind of sort of talked about on a previous webinar. But that whole concept of synthetic data generation will help us in terms of replicating a more production-like or a more real-world-like scenario in our testing. And the last thing I'll talk about in terms of the significance of evaluation in LLM apps is the ongoing evolution, right? So the release of an LLM application is not the end of its development cycle. It's really just it's merely a stage, really, if you want to think of it that way. After deployment, that model enters a phase of ongoing evolution. It's continuous evaluation is required to adapt to new data, emerging use cases within your applications, changing user behaviors. So this evolution is a cyclic process when the model is constantly updated, reevaluated, and improved. So it's a commitment to perpetual refinement, and it ensures that the application matures and remains effective over time. All right, and almost to the end of what I'll present to you before I transition over to Abhilasha. Just real quickly, I want to hit on some of the variations of impact in LLM apps, and I'll probably ask Abhilasha to kind of chime in on this as we transition for some input as well. But when we talk about variations, right, these are important in really getting to the heart of evaluating and keeping those models trained and tuned, I guess you could say. And the first variation that you can, so these are parameters, right? These are things that we can actually, adjust and for lack of a better technical term, play around with, right, to make sure that we are using them to do our evaluations and to tune the LLM. And the first one is prompt tuning. And the way you communicate with an LLM is through prompts, and that can dramatically alter the outcome. So, and that's really because the model's response is highly dependent on how the question or the statement is framed. So, for example, summarizing things like a news article, that requires the LLM to extract key events and statements, really focusing on the factual information and the main narrative. On the other hand, things like summarizing a medical conversation, for example, may require attention to different details such as symptoms, diagnoses, treatment plans. So understanding the nuances of prompt tuning is essential to obtaining really the most relevant and accurate responses from the LLM. And then we have embedding retrievals. This is when integrating custom data with LLMs, the retrieval of the correct embeddings is crucial. So embeddings are high dimensional vectors, and they represent the semantic meaning of the text. That enables the LLM to understand the actual context. So you can see that's really important in terms of tuning the LLM. So selecting the right embeddings and similarity metrics determines how well the LLM can match queries with the information in the data store. And then we have model parameters. LLMs can operate with a set of parameters that can be tuned after to alter their behavior. So parameters like, say, temperature control, the randomness of the output. Top K determines the number of high probability vocabulary tokens to consider for each step. And repeat penalty prevents the model from repeating the same lines, right? So adjusting these parameters can help tailor the LLM responses. And that's going to make maybe to make it more conservative or more creative, depending on the desired application, right? And then I'll wrap this up to say too, with data store, for more sophisticated LLM applications, especially those deploying RAG, right? Retrieval augmented generation. The strategy for data storage becomes significant. So you've got to consider how storing supplemental data, whether keywords or full documents, and how that data is retrieved and used by the LLM. Those decisions on storage affects how effectively and accurately the LLM can access that relevant information and answer queries or perform certain tasks, right? That's going to impact our overall performance of the app. So with that, Abhilasha, anything you'd like to add? I know you've got a lot to say around this space, especially on the variations. I'll turn it over to you, and feel free to chime in on this slide as well. I'll just turn over the presentation powers to you too. You can just take it.
Yeah, thank you, Scott.
Sure.
I'll just share my screen. I hope my screen is visible.
It is.
Yeah. So thank you, Scott. That was a good overview. So like we all understand now that we have like a very rich ecosystem of things we can do using LLMs and the toolings which exist to facilitate us to do the things we want to do, to make use of the power of large language models and how we can control that. So that is where we saw the variation of how we can create the impact or what problem we can solve and how we can tweak it. So that's where we looked at these different parameters. And now still, like, in order to take a solution into production, the evaluation piece is something which becomes very important in order to like make sense of the complete problem statement and the LLM getting applied to the problem statement. So to start with, like when we talk about evals and evaluation, just to like give you a view of what are the two types of evaluation you would do when you're dealing with the LLM. And that's where the first level evaluation would be the LLM model evals, wherein we are actually evaluating which model is most suitable for our use case. And this would start with the actual foundation model team working on the different parameters for that model and defining the behavior, assessing the positives and negatives of the model, what the model is good at, or if there are any weak points, how that can be improved, and things like that. Now, in a typical enterprise use case also, when we are trying to get started with a problem statement, we are trying to apply a model, we would definitely want to assess which model would suit the problem appropriately, because definitely models vary in their performance. Like some models are considered to be better in maybe question answering versus some model could be better in summarization. And accordingly, depending on the problem we are trying to solve, we would pick up the model. And that's where this diagram shows like for the same input data and the prompt template, you would try to like test out different models and see and validate your responses. So this would be one type of evaluation which would be done in order to assess like which model would suit our needs. And definitely, like as a part of the LLM evaluation benchmark also, when these models are like rated, so there are multiple papers which actually delve into trying out these models with different data sets and different problems. So all these listed data sets which you see here, these are basically different scenarios which we try to put the model through, like if it is a reasoning problem, if it is a maths problem, and accordingly, so these data sets are like maybe one or two problem statement discovered, and then there is a wide variety of examples, and the model is tested across that to actually benchmark its performance. So that is one level of benchmarking that happens, and that is even before it comes to us to use it further. So this will actually set us the first benchmark to understand like which model is good at what. And that's where you can see this table, which is an indication of how different models fare on different activities. But now, when we move into actually using the model into the application, so when we talk about LLM-based applications, and that is the main thing what we are talking about in this current webinar. So here it becomes important to first understand what kind of application we are developing and what kind of tasks we are trying to perform with the help of LLMs. Because again, there is a variation there. Because it is not a very straightforward yes-no kind of situation. Because since the power of LLM is such that it fits into a wide variety of tasks and problems, accordingly, like when you're trying to fit in, so accordingly you have to think of how you would evaluate the model, or how you would evaluate the performance of your model. So just to like segregate, we can see this, that overall, if I have to say split the tasks which a LLM powered application can perform, so it can be of two types on a high level. One is where success is not clearly defined. So something like a assistant or a chatbot where you actually cannot clearly say a yes or a no, or a score to actually measure if the bot is performing well. So suppose if you have a bot which is supposed to assess your answer and then maybe ask a follow-up question. So again, that is something which you cannot clearly like identify. Or if it is just a question answering, again there, it would depend on the kind of question answering you're trying to solve. If it is a very structured question answering, it could still fall on the second like branch here, where the success is clearly defined. But I would say clear definition of like a problem statement could be if you're using LLM to say generate code or generate some kind of content summary. So you have some parameters to assess and measure your data which is getting generated. So again, the success can be more clearly defined in those scenarios. And again, there are two categories. It can be like a straightforward solution, a single solution, or it could be again multiple paths to that solution. So why understanding this is important? Because accordingly, when you're trying to evaluate the application success, you would have to think through that in what bucket this falls, and accordingly you'll have to define your evaluation mechanism. So this is important to define the strategy of your evaluation. Now, the second important thing is when you're doing a system evaluation, because here you have finalized the model which you are using. Now you have to finalize, or you may say assess the other parameters which will add to the variation of your output. And that is where prompt is one very important factor, because by modifying the prompt, you can actually control your response. So we all know that. That's all about how controlling the model using prompt. That is one important aspect. And that is one way you can actually evaluate your model, by trying out with different prompts, measuring the output performance, or maybe have some scoring mechanism, and then assess and compare the response, and finally benchmark that a specific prompt is giving better results than the other. So that would be your system eval when you actually get into evaluating your system performance, when you have decided your model. Now again, in this scenario, when you're trying to evaluate your system, traditionally there are many metrics like Blue Rouge, and then you have BERT score. So these are different metrics which have been traditionally used in NLP to measure the performance of your NLG or NLU models, and say score it and then assess how it's performing. And then again, of course, and these are based on, like, if you can see here, these are the word-based model where you have mechanisms like you count the n-gram mechanism, or you check the number of the number of keywords coming in, or things like that. Now, Levenstein distance is more to do with similarity. So it's to do with the embedding similarity between between the expected result and the actual result, and then trying to give some score around that. But now when you're using LLM, and as you see, like, the variety of tasks where you're actually applying this, it is not very straightforward to apply these traditional metrics. And that is where this green box which you see, which is applying your LLMs itself for measuring your evaluation, or for performing your evaluation. And here again, there are different mechanisms and different frameworks which come into picture. So GEval is one such open source mechanism to say, which has some predefined evaluation parameters which help you assess and score your response on different parameters. Prometheus is one of the LLMs actually which specializes in evaluation itself. So it's like a special LLM which can be used for evaluation, and it provides a mechanism to provide your specialized prompt on what you're trying to evaluate. So similarly, all these scores which you see, those are driven by LLMs itself, and then that's where they bring in the power of how you would assess your LLM performance. So definitely, whenever you are building a strategy to evaluate your LLM applications, you have to bring in a second LLM to evaluate the performance. It may be the same LLM, or you may bring in a different flavor of LLM, so that it brings a new perspective to your evaluation, and it can bring in more objectivity into what your first model performance is. So with that, when we talk about LLM evals, and evals is more like a unit of evaluation which you would perform with a given input and an output, and for the wherever there is context applicable. So when you're actually adding your RAG in your like LLM application, so you're bringing in your context. So again, that brings in another layer of evaluation. So with these three things in place, you would have a scoring mechanism, and then you would have a threshold to decide whether it is good or bad. So this is the base on which there are multiple. So when we actually started off with using LLMs, people were doing it more manually, trying to assess and measure how the LLM is performing, and trying to say observe the different results. But now there are so many tools which actually make this job much more smoother and easier. So many frameworks which perform this activity for us. Like, they give us the platform to be able to easily evaluate your LLM application performance. So if we talk about RAG pipeline, now in a RAG pipeline, if you have already worked with LLMs, you would be aware that basically what we do with RAG is we add a you can say the best suitable context to your input and give that augmented data to the LLM to finally give you the response. Now, with this in place, so this is the base RAG architecture. Now, in that, you bring in the evaluation block, which will actually bring in and compare the different aspects of the RAG pipeline to actually show you how good or bad the response is, or how good or bad even the context is. Because in a RAG pipeline, the context is a very important piece to assess evaluation. So if you're just evaluating the response, it is only 50% of how much you can control it. Because your LLM behavior is controlled by the context or the extra knowledge which you're giving to the LLM. And that's where you need to evaluate whether you're giving good context also. And that is how, so we will look into how a RAG evaluation block looks like. So this is now, yeah, so before we actually go into that, we will look at some of the frameworks which are available today for facilitating the evaluation of these applications. And that is where the first one which I'll be touching upon is Phoenix. It is an open source tool which has multiple flavors. So we have spoken about LangSmith and LangChain in the past, and they bring in like a complete perspective of handling your LLM applications. They bring in the eval layer also. But again, Phoenix is another very specialized framework which brings in the monitoring and observability to the best control, you can say that. So you can actually take span by span. So whenever you have like so span here is like, you can say a specific call you're making to the LLM. Now, in that call, you're retrieving something, you're augmenting, and then you're making a call. So you can actually evaluate each and every span by assessing the input, any extra context you're providing, the output. So that is your retrieval span, which you're actually taking in and feeding into your eval template. So Phoenix provides some sort of existing parameters, or you can say criteria or conditions against which you would like to evaluate your model, be it say hallucination or context retrieval accuracy, so things like that. And each of these frameworks which we see, they have their own set of parameters, or you can say defining criteria, and then you can also define your custom parameters which you can tweak with the means of your prompts, and then you can get the desired results. So again, the template is the piece where you're actually controlling the behavior of your evaluation. That's your eval template. Then your model parameters and your evaluation LLM. So whether or not you're using the same LLM, this is a very important piece, because LLM is only going to evaluate the LLM. It will judge how good or bad the results are. And then again, you can control the parameters of your LLM, the temperature and other things here. So based on this, your eval framework will provide a output format. So as part of the template, you would define like what kind of response you're expecting, whether you're expecting the model to give a scoring, or whether you're expecting the model to give a yes or no binary kind of answer. So accordingly, the model will give you a response, and you can actually then like metricize it and measure it for a big data set and take it forward to benchmark the results. So similarly, there is another framework, a popular one called Ragas. So Ragas is a specialized one for RAG, as the name suggests, and it specializes on how you compare the different parts of your RAG pipeline. So as you know, like in RAG, you will have question and answer and a context. Now, whenever you're actually evaluating a model, you have to have a ground truth or a baseline. You can say a golden data set, what we call. So that is actually, that will have all the expected results from your model. So that will help you compare the results with the actual result, with the context. So basically the different flavors here. So context is what is getting extracted. Now, whether the context is actually having the relevant information. So the relevancy is one thing. Whether the context, so to get the answer relevance, you would compare the context with your answer. So you would compare the context with your question. So how precise is the context for the given question? Is it accurately retrieving the correct context? Because in a huge data set, being able to retrieve the correct context is the more important problem to actually solve and get a good performance out of your RAG pipeline. So that is something you would really want to evaluate and improve upon. Similarly, again, on the generation part, so the answer which got generated, whether it is accurate as per the context, accurate as per the ground truth, and relevant as per the question. So the end-to-end evaluation and the specific block-to-block comparison is done as part of RAGA. So you have the end-to-end evaluation, you have the answer semantic similarity. So you compare the answer with the ground truth and the correctness, whether how correct it is with respect to what is stated by the ground truth, or is it deviating? Is it giving a factually wrong statement? So those things you can control by defining your evaluation layer, incorporating all these aspects to control the quality of your results and have a more predictable performance. Now moving on, the other aspect, or in fact the first point of your pipeline is, as you saw here, right? So having this ground truth or the golden data set. So how do you have that? Now again, you can actually manually go and create, but sometimes it will become difficult to manually create your data set. And that is where Ragas has a solution for that, where you have a test data generator as part of your Ragas, which actually works on a evolutionary, evolutionary generation paradigm. So basically it evolves. So based on the seed question, based on the chunk of data which is available to it, it will evolve and build in questions which will actually bring in more aspects of, so here you see these three things, right? Reasoning, conditioning, and multi-context. So basically the evolution process will bring in these flavors of, so it will generate a question answer set which will have the flavor of reasoning, which will have the flavor of conditional. So if this is the case, then what should happen? Those kind of questions. And also a multi-context kind of question. So if it has to refer to different sections of a document and answer. So those kind of questions, so that it brings in the variety in your test data to measure the accuracy, or sorry, measure the performance of your pipeline. So moving on, again, deep eval is another such framework which provides on the left side all these parameters which you see, or metrics you can say. These are all the different evaluation aspects which are covered as part of deep eval. And then again, you can define your test cases by providing the input, the expected output, the actual output, the context, and then some additional parameters, like if you want to give some additional list of steps, or if you want to add some more like threshold. So those things you can control and actually bring in the behavior of control on top of your evaluation mechanism by using this framework. So this is one of the frameworks. Similarly, this is another framework which I would like to briefly touch upon. So basically, if you have seen or attended any of our earlier webinars or looked at some of our videos. So Autogen, you must be aware of Autogen. Autogen is a library provided by Microsoft, which gives you a platform to define agents which mimic the behavior of a real human agent and perform certain tasks. So similarly, this agent eval is a part of Autogen, which brings in the flavor of evaluation. So again, it has two aspects to it. It has a critique agent and a quantify agent. So what the critique agent does is, it generates the list of criteria based on which you want to evaluate. So it's like the criteria is defined first by the critique agent, and then the quantifier agent will actually do the evaluation process, do the assessment, and then generate the result. So here, if you can see, so this is the kind of template and messaging we provide to the critique. And then again, this can get in more details depending on the problem at hand. You would ask the model to generate the list of criteria you would like to measure for your problem statement. And then that list of criteria you will provide to your quantifier agent, which will again assess your results with your expected results and measure the performance of your application. So that will give the utility of your LLM powered application. So this is another very powerful, and this is a evolving framework which gives you a control on the evaluation process. So and of course there are many others. So there's TrueLens, then LangChain has Langsmith, which brings in the flavor of observability and evaluation control. But more or less, like, they are trying to solve the same problem, and they are trying to provide a structure to your evaluation process. So depending on your problem, you would pick up the metric and grading suitable for your problem at hand. And the second important step would be to prepare your golden data set. Making use of manual steps or tools like Raga, you define your synthetic data, which will help you assess and evaluate the performance of your application. Then you would build your eval template, whether it is an existing template you're using, or using all these frameworks, you can define your custom templates, wherein you can define your custom, you can say, criteria based on which the model will score, and you can have some kind of control. So see, being LLM, if you have worked on LLMs, you would have known that they are not always predictable. So you have to bring in the layer of control on top of the evaluation framework also, by means of an output format you're trying to impose on your result, by bringing in different scoring mechanisms, so that your like the behavior is more predictable. So similarly, like generally, like how we do is, we would try to provide a grading or a scoring mechanism to keep it simple, that will help us to define the metrics and also measure the metrics in the future. So instead of having more subjective assessment, a more scoring based assessment would be more effective. Also, the LLM which you want to use, so usually we start with GPT-4, given it is giving a decent performance in most of the problems. But then definitely you can look at the other LLMs. So there are LLMs like you have Llama 2, then you have Palm, you have Mistral 7B. There are more and more LLMs and SLMs which are coming up. So you can decide on which LLM you want to use for your evaluation, because again, evaluation is something you would be doing iteratively. So cost is something you may have to look at, and that's where GPT-4 can become a costly option. And GPT 3.5 definitely would be a more cost-effective option. And then you can look at the other LLMs also. So once you define all these aspects, you would run your eval template on your data set. You would generate the metrics, and then you can traditionally apply your metrics of precision, recall, to assess and have like a objective measurement of the performance. Again, there will be, so you can make this objective, but then you will need some amount of manual review of how the results are, and to get a more comfort on how your LLM is performing. But then by giving this like step-by-step approach of evaluation of your LLM application, you can definitely bring in more control on how your LLM application is behaving. And you can actually, I would say, bring out the best of LLM with a control on the bias aspect of it, the hallucination aspect of it. So you have different parameters to measure and control these aspects also of the LLM, which are like known issues, right? So that is how you can actually control and bring out the best out of your LLM applications. So with this, we come to the end of the presentation. I'll quickly show you some of the examples. So we are actually out of time. So maybe I have some of the like existing, you can say, examples, which I will quickly show you. So this is one example where we have used the Ragas synthetic data creation. So this is actually the generator which you get from Raga's framework, and it works with LangChain as well as Llama Index. So with the two popular frameworks, you can actually work with it, and you can give the distribution of how you want your questions to be. So whether you want more of simple, or you want more reasoning based questions, multi-context questions. So these parameters you can provide, and then you can generate your question answer. So the data set, which is the first important step of your evaluation journey. So you can generate your data set here. So this is where your questions, your context, which is actually the data which was used to generate this question, and the answer. So this gets generated. So similarly, you have for your Llama index docs, where like the format is same. It's just that if depending on the kind of connector or tool you're using, you can use, and then you can convert to pandas, so that you can analyze, download, and use this data for your evaluation. So this is how you can generate your data. Then once you have generated the data, you can use a tool like Phoenix. So Phoenix is a very very, you can say, user-friendly tool, which gives complete control and visibility of how your application is performing. So even if you've already used something like a Langsmith, which LangChain provides, so it gives you a complete control on what are the different aspects getting executed, and what is the output, and like what is the intermediate output. So things like that you can actually control. So this is one example which I've taken from the Phoenix documentation. So here it makes use of the Google file storage system, and then it's actually referring to data on the documentation on Arise, and then using that, it is building your query engine, and now query engine is generating the questions, and then you are running the questions on the engine to get the answer, and then you are actually evaluating the query. So you are actually splitting your content in a way that you are actually either as a whole, you're trying to evaluate how the answer was, or you're actually doing it on a piece by piece basis. So if your, say your question was answered in a step-by-step manner, so you can actually do the evaluation of every piece and see how well it performed. So that is what we are doing here. So you can see that these are some of the evaluators which are provided by the Phoenix. So you have hallucination, you have QA correctness evaluator, you have relevance evaluator. So you can define these evaluators, and they have their predefined behavior, you can also define your custom evaluator. So I will show you an example for custom as well. But the idea is, so you are actually giving your, say, questions and answers generated and evaluating against your ground truth or against your questions, answers, depending on what you're trying to, in fact, your context also, depending on what you're trying to assess, whether you're trying to assess the accuracy based on the context, or you're trying to assess the accuracy based on the ground truth, or you're trying to assess the hallucination level. So again, there you will assess based on your context and ground. So this is how you will actually be able to view the dashboard in the Phoenix. So in fact, I have a dashboard open. So here you can see the traces. You can see what input was provided, what output was provided, what evaluations were done, and then sorry, I think I clicked something. So basically, yeah, I'll have to run the whole thing again. So let me show you here. So basically, you can see what evaluation was run and then what was the result. Whether it was, so something like an hallucination evaluator will actually tell you whether it was factual or whether there was some element of hallucination. So similarly, you can actually see the results of your evaluation here in the in your desktop or your dashboard for your Phoenix. So with this, you can actually give get a control on how your model is behaving. So just to give you a view of one of the custom evaluators which we have defined. So this is something we did using Langsmith. And here you can see it's a simple template where you're using an LLM and you're instructing the LLM to score your model input, comparing your input and output, and you're giving the points based on which the comparison should take place. Then you're giving the input output, and then you're asking it to reason step by step and come up with a proper score and print the score at the end. And you can actually say that reconfirm the score only with a some title like a scored coverage. So you're actually like explicitly asking the model that it should give you the output in a specific form, so that you can then take it forward and use it in a way you have to. Okay, so this actually like shows you different flavors of how you can use your frameworks and you can build your evaluation strategy to ensure that you're able to make use of the power of LLMs and apply it to your enterprise problems. So with this, we come to the end of our presentation, and we can take up questions. Before that, if Scott, you want to add anything?
No, that's fantastic, Abhilasha. So thank you very much.
So maybe we can take up the questions.
Yeah. So I see a few questions that we have received. James want to know, how do LLM applications handle bias and fairness concerns in data processing?
Yeah. So basically, like for bias, you can actually control, first of all, the kind of data which you're using to even define your evaluation framework, like the data set preparation, which I showed just now. There you can control the bias so that your LLM is able to handle like variety of data without any bias injected in the data. So that is one layer of control which you can bring in. And also, secondly, you have some evaluation frameworks which specifically measure the model performance to assess if there is any bias or absence of fairness in the results which are getting generated. So you can actually measure those using the frameworks like, I think Ragas provides that.
Ragas.
And yeah, and some of these frameworks, because this is a very important ask. Whenever you are dealing with LLMs, you definitely don't want to have bias and hallucination in your output. So this is something which these frameworks provide. they give you a structure to control. And then, of course, you'll have to manually assess and monitor it to ensure that nowhere it picks in. Hope that answers.
Thank you, Abhilasha. The next question that we have is from Ralph. He wants to know, can you elaborate on the computational resources required for training and deploying LLM models?
Okay, so yeah, this is the topic. I think this is something we are planning a complete webinar on, but definitely, I mean, in short, if I have to say, this would require a reasonable, like a GPU compute. But then, if you're going with LLM models, like if the open source models, like a Minstrel 7B, I don't know if you have tried any of these models. If you just try on, say, Collab, because if you're just seeing how it performs and things like that. So you would see that the performance and the latency is really slow. That just shows how much compute these models require. And that's where recently, if you have heard of SLMs, the small language models, which are becoming more and more popular because these models have shown decent results. And when you have a specific problem at hand, you can actually look at using some of these SLMs. Phi2 is one example, which is like a recent one, I think, by Microsoft. And so you can actually, so the compute is like very less compared to what a LLM would need. For LLMs, when you're talking about TPUs and GPUs, you can actually run SLMs on your your normal systems. So that is the kind of edge these SLMs bring in. But definitely, like, to answer this question in more elaborate, like maybe we would need a complete webinar, and we can plan it in our next webinars.
Yeah, and I think SLMs are going to be an important thing for the future too, right? Because I think what we're discovering is maybe you don't need to know everything about everything to utilize, you know, a language model, right?
Absolutely. So it could be specific to your problem, and you don't need to have the complete knowledge base.
That's right.
So, yeah, right.
So the next question that we have is, how do LLM applications handle adversarial attacks or security threats?
So for like most of these models, like if you're using a foundation model which is actually defined or available as an API, so it is a complete ecosystem. If you're say if you're using an OpenAI on Azure, so the Azure ecosystem itself provides you that security against the adversarial attacks and threats. If you're using something like a Claude, you can go with an AWS infrastructure, where again, the cloud will give you the capability to ensure that you are protected against these kinds of threats. Now, if you have your own model, like an open source model, which you are trying to set up, then definitely this is something which will be part of your deployment architecture, where you have to ensure that you are considering different aspects of security and adversarial attacks to like ensure that you are safe and not open to like surprises here. So yeah, that is what I can say here.
Thank you, Abhilasha. That was the last question. So I would like to conclude the webinar saying thank you to both of our speakers for sharing your invaluable insights, and a heartfelt thanks to all of you for being a part of this webinar. So before we conclude the webinar, mark your calendars for our next webinar that is scheduled for 29th of February, where we will be exploring transforming testing practices, unleashing the power of AI in scriptless test automation. Until then, thank you everybody for your active participation, and stay tuned for more engaging discussions in the future.
Thanks, Tanishka.
Thank you.
Thanks, everyone.
Thank you. Thank you.